alaikum. Hope you are doing well. So this side Maruk. So currently I'm teaching you the chemistry, which is very basic. Like you can say the chemical equilibrium. So did you know about anything about the chemical equilibrium? As we know that equilibrium is very important in our daily life as well. So you must have to understand with the basis or with the causes or effect of chemistry. So let's start chemical equilibrium. Today we will talk about the chemical equilibrium. Alright, so here we go, that chemical equilibrium. What is chemical equilibrium? Basically, it is, you can say that the forward reaction and the backward reaction both are equal at the same time, happening at the same time. You can say that it is a state in a chemical reaction where a forward reaction, it means like this reaction, is equal to the backward reaction. Now you understand it. Like for example, if I will say if the forward reaction occurs, at the same time the backward reactions also happen. Like for example, that A plus B is converting into A, or maybe it converting into C or D. Alright. So how? Because whenever they both are helping or they both are occurring the same way. Its representation is the arrow like this. Like forward reaction also occurring with the backward reaction, not only one. This is only the reaction which is irreversible, which we can't reverse it. Alright. So basically in this one you will see that, see here, like basically you have to do this. The initial concentration of the reactants is converted into the concentration of the reactants which we added the A, B, C, D. Like they all are converting into in the same way, in the same shape, or in the same at the constant speed. All right. So first we will talk about the general form of this. You can see here, this is basically the general form. This is basically the general form. Like see that if I am talking about anything, for example this one, so you can say that A plus B. Now these both are what? These both are reactants and they are converting into the products. C plus D. Again with the constant speed, with the same, like if I am converting this reactant into the products, again the same time products will be converting into the reactant. Not like that only reactants are converting into the products and that is basically the irreversible. Okay, and this is basically called the reversible reaction. So whenever they both are converting into the with the same constant speed or with the same concept. Okay, so you can say that reaction is basically in a chemical equilibrium. So forward reaction and the backward reactions happens at the same time. All right, hope you understand it. Like for example, there is example that hydrogen plus iodine. Okay, now hydrogen and iodine, when you mix both hydrogen and iodine, that is hydrogen plus iodine. Now you are converting it into the hydrogen iodide. That is a forward reaction. All right, but again they both are converting into this one, hydrogen iodide. Again they are converting back into this hydrogen and converting back into the iodine. So that is basically the irreversible reaction, the reaction in which we are converting back. All right, not only the products are converting into reaction, but also the reactions are converting, reactants are converting into the products, and then again products are converting into the reactants. Hope you understand it. Then we will talk about the dynamic equilibrium. Dynamic equilibrium occurs when the rate of the forward reaction become equal to the rate of the reverse reaction. Same like we are talking about the equilibrium, it is also the name of the same thing. All right. Now again the we can consider this example with it. All right. So it's having like it having characteristics that occur in a closed system. Closed system means what? Like the energy is not lost. Clear? Like with the same one reaction is with the same energy reaction is happening with the same energy, reactants are converting into the products. Again with the same thing, products are again converting into the reaction, and this one is the main thing. This is the sign of it. But if you talk about the irreversible, it means it will not reverse. Okay, it will not reverse itself. So its arrow is this, like it will be not, these products are not converting again into the reactants. Then concentration of the reactants and the products remain constant, same, not changed. Okay, and the both reaction continue at the equal rates. Hope you understand it. Then we are talking about the law of mass action. It is basically representing the equilibrium also. Okay, so we will talk about the law of mass action. So here we go again with these are the products, or sorry, reactants, and these are converting into the products. All right, but not this arrow is showing you that it is irreversible. Irreversible, in which products are not again converting into the reactants. Alright, in simple, you can say the rate of a chemical reaction is directly proportional to the products of the concentration of the reactant. Similarly, you can say this is the equilibrium constant, the sign basically that is assigned to it. Okay, you can see this, you can see these are the constants. Again with the A, these are the constants with the B, but now you can see these are you can say that directly proportional to the A is let me tell you that A, B, C and D are the concentrations of the A, B, C, D respectively. Alright, or respectively you can say. So the general reaction is, we will elaborate it. Yeah. So you can say that like A is converting into B and the products are forming SD. Clear? Now rate is what? Rate is here. Rate is equals to A into B. Now again at equilibrium you see that the K constant was what? Constant was basically C D along with A and B. You can say with their constant ones. So you can say that the A, B, C, D are the concentrations. Alright, and the small a, D, C, B all are the coefficients in the balanced equation. So how it will be the balance? The same example come here. H2 plus I2 is again converting into 2HI iodide. Clear? So again it will convert into this one, then again it will be converting into the this one. So depends upon the concentration. It applies the reversible reactions only and helps to calculate the equilibrium constant. And the one thing is that the temperature should remain constant, not decreasing, not fluctuating, not increasing. It will remain same at the start of the equilibrium. So now you will talk about the types of the equilibrium. All right. So we are talking about now the types of equilibrium. So you can say the first one is that the homogeneous equilibrium, where all the reactants and the products are in the same physical state. Now you can see in this example that homogeneous means the same thing. All right. So for example, again you can say that homogeneous means same and heterogeneous means different. So we are talking about the homogeneous. Homogeneous in which, see, this nitrogen is also in the gaseous form, this hydrogen is also in the gaseous form, and the reaction product is also in the gaseous form. It means that all the reactants and products are in the same state, means the state of matter, whether it's a gas, whether it's a solid, whether it's a liquid. So then we will talk about the heterogeneous equilibrium, in which the both, like the reactants and the products, are not compulsory to follow this rule, because maybe they are in the, like you can see here, this reactant is in the solid form, this reactant is in the then the products are, one is in the solid form and one is in the gaseous form. So doesn't follow the homogeneity. It is basically the heterogeneity. Now, how you will recognize the equilibrium, that the concentration of the reactants and the products will remain constant. No visible change in the system, like change of the temperature or anything. Equal rates of the forward and the reverse reaction, like in the speed where the reactants are converting into the products, again with the same speed products are converting into the reactant. So constant pressure in gaseous system, like if you are talking about the gaseous one, so the pressure should be remain same. Color in the reaction also should be colored substances, like in the colored there should be a colored substances, clear? Then we are talking about basically the factors that are affecting basically the equilibrium. All right. So in this one, we will talk about the Chatelier principle, which is talking also about the equilibrium. So you can say that if one or more factors that affect an equilibrium is changed, the position of the or equilibrium shifts in the direction that reduces opposes the change. It means that if a system at equilibrium is disturbed, like you change the concentration, you change the temperature, or you change the pressure, it shifts into the direction that opposes the disturbance. Alright, like it will change its direction. So cancel the change and restore the balance. Hope you understand it. Like whenever you can say that whenever the equilibrium is disturbed, whether with the concentration, whether with the temperature, or whether with the anything else that is affecting the equilibrium set, it will be not converting properly into the you can say the equilibrium, or you can say the chemical equilibrium will not be obtained. So here we go, that is a change in concentration. Like if you increase the reactant concentration, shifts equilibrium towards products. Okay, like reactants are directly converting into the products. If you will change the reactants, okay, or if you change the concentration of the reactant, obviously reactants will increase, so they are fastly converting into the products. Simple. When you change the pressure, so increase the pressure favors the side with fewer gas molecules. Like obviously when the gas is basically directly affecting the gas molecule, so where in the product or whether in the reactants the gas molecules are more, the equilibrium will be shift there. Then changing the temperature, like if you increase the temperature or something like that, then what will be happen? Endothermic reaction, in which heat is evolved. All right, energy will be lost, so they will not reach to the equilibrium. Equilibrium will be not occurred. And when you add the catalyst, basically catalysts are the substances that speed up the reaction. So obviously when you add a catalyst, it will speed up both forward and the reverse reaction, but does not change the equilibrium position. Alright, these are the one things that are added in the reaction, but without adding themselves, they are increasing the speed of the reaction. So it will not affect anything. Then you will see the industrial application of the Le Chatelier principle. Basically, the Haber's process. It is basically the process in which we manufacture the ammonia. Now you can see that hydrogen plus nitrogen will form again here. It this is called the like equilibrium state, in which they are converting again into the products. Reactants are converting into the products are again converting into the reactor. How and when there is a high pressure, moderate temperature, and iron catalyst only. Iron catalyst is working here. All right, but although it's not adding in it, because catalyst is one thing that is working with it, but it will not involve themselves inside the reaction, or maybe not involved in the products. Then there is a contact process, that is basically the manufacture of the sulfuric acid. So again you have to do sulfur plus oxygen, and they are forming the two molecules of the sulfur with the oxygen, and they are again forming the product sulfuric acid. Again it is converting into the reactant, again it will convert back into the products as well. But the condition is that the catalyst should be the vanadium pentoxide, moderate temperature should be required, and the high pressure, because they all are mostly the gases, so the reaction will be accurately happen. All right, hope you understand it. If there is any question, you can ask freely. Thank you.